somewhere beneath the gray waves of the English Channel, where ferries cross every day without a single passenger giving a thought, there is a forest, not a shipwreck, not coral, a forest, or what remains of one. Drowned tree stumps still rooted in soil that has not seen sunlight in 8,000 years. Fishing trawlers occasionally drag their nets across the seafloor and pull up some that should not be there. A barbed antler harpoon, the jawbone of an animal that vanished from the earth millennia ago, once a tooth so large it could only belong to a mammoth. Each find is small. Each find is also impossible, in the quiet way that makes a person stop and stare at an object in their hands and ask, how did this get here? The answer is that it didn't get here. It was always here. The sea moved in around it. Researchers have a name for the vanished land beneath that stretch of water. They call it Doggerland. And Doggerland is only one fragment of an entire world that no longer exists, a world that was lost not to war, not to fire, not to any of the disasters we usually imagine when we think of civilization's ending. It was lost to water, slowly, and then all at once. 12,000 years ago, if you could somehow stand on the surface of the earth and look down at it the way you might look at a map, you would not recognize your own planet. Ice sheets nearly 3 kilometers thick, taller than most mountains, buried the entire northern half of North America and stretched across Scandinavia and into northern Europe, pressing down on the crust of the earth with a weight so enormous it physically deformed the land beneath it. The oceans, locked into all that ice, sat roughly 120 meters lower than they do today, lower by the height of a 40-story building. At that sea level, Britain was not an island. It was simply the western edge of mainland Europe, and you could have walked there across what is now open ocean without ever wetting your feet. Lower still, and you could have walked from Siberia into Alaska, crossing an entire continent's worth of land that is now the floor of the Bering Sea. The islands of Indonesia were not islands at all, but one single, unbroken landmass that geographers now call Sunderland. None of the coastlines you have ever seen on a map existed. None of the borders. None of the familiar shapes that we have memorized since we were children, tracing them with our fingers on a globe. The earth wore an entirely different shape, and the people living on it had no way of knowing that the ground beneath their feet was, geologically speaking, already living on borrowed time. And then, over a handful of thousand years, an eye blink by the standards of 4-billion-year-old planet, though it would have felt like the slow unraveling of the entire world to anyone living through it, almost all that frozen geography disappeared. The ice did not melt politely. It broke, catastrophically, in pulses so sudden that sea levels could rise by more than a dozen meters within a single human lifetime. Coastlines that families had known for generations moved inland by hundreds of kilometers in the space of a few decades. Creatures that had walked the earth for hundreds of thousands of years, mammoths, giant sloths, saber-toothed cats, vanished completely in what may be the fastest mass extinction in the planet's recent history. And then, just when the thaw seemed to be settling into something survivable, the cold came roaring back without warning, for reasons that climate scientists are still debating in research papers published this very year. This is the story of what happened when the last ice age ended. It is a story written in drowned forests and flooded river valleys, in the bones of animals that no longer exist and the quiet, scattered remains of human settlements abandoned in a hurry. It is a story of a world that fell apart and rebuilt itself into something new, and in doing so, made the world you are lying in tonight even possible. So let your body settle into the dark. Let your breathing slow, the way water slows when it finally finds its new shoreline. Tonight, we go back to the edge of the ice, to a planet standing at the threshold of the most dramatic transformation it had undergone in over 100,000 years. To understand what was lost when the ice melted, you first have to understand what the world looked like at its coldest, at the precise moment when the last ice age reached its absolute peak. Scientists call this moment the Last Glacial Maximum, and they dated to approximately 26,000 to 20,000 years ago. This was not the beginning of the Ice Age. Glacial and interglacial periods have been cycling on Earth for roughly 2.5 million years by this point, driven by the same slow astronomical rhythms that would eventually end this particular cold period too. But 20,000 years ago marked the coldest, most extreme expression of that cycle in recent memory, the deepest point of the freeze before the long, complicated process of thawing began. At its peak, the ice covering the planet was almost impossible to comprehend in scale. The Laurentide ice sheet alone, the massive dome of ice that covered most of present-day Canada and extended deep into the northern United States, held an estimated volume of ice large enough that, if it melted entirely, it would raise global sea levels by more than 20 meters on its own. In some places, this ice sheet reached thicknesses of 3 to 4 kilometers. To put that in perspective, if you stacked Mount Kilimanjaro on top of itself nearly twice, you would approach the thickness of ice sitting over what is now Hudson Bay. A second great ice sheet, the Scandinavian ice sheet, performed a similar function across northern Europe, burying Scandinavia, the British Isles, and much of what is now the Baltic region under ice that, in places, rivaled the Laurentide sheet in thickness. Smaller but still substantial ice caps covered parts of Siberia, the Alps, and the Andes. Antarctica, already covered in ice today, held even more ice than it does now. Altogether, scientists estimate that ice sheets at the last glacial maximum covered roughly 8% more of the Earth's land surface than ice covers today. All of that ice had to come from somewhere, and it came from the oceans. Water that would otherwise have remained in liquid form in the seas was instead locked up as solid ice on land, and the result was a dramatic, planet-wide drop in sea level. Researchers studying ancient coral reefs, drowned cave systems, and sediment cores from around the world have established with a high degree of confidence that global sea levels at the peak of the last glacial maximum sat approximately 120 meters lower than they do today. Some estimates push slightly higher, to 125 or even 130 meters, but the consensus settles firmly around the 120-meter mark. This single number, 120 meters, is the key to understanding why the map of the ancient world looked nothing like the map we know today. A drop in sea level of that magnitude does not just shrink beaches. It exposes entire continental shelves, the gently sloping underwater margins that surround every continent, transforming them into dry, walkable land. In the region we now call the North Sea and the English Channel, this exposed continental shelf created an enormous landmass that researchers today call Doggerland. At its largest extent, Doggerland connected the landmass of Britain directly to mainland Europe, creating a single unified peninsula stretching from what is now France and the Netherlands all the way across to what is now England and Scotland. This was not a narrow bridge of land. It was a substantial territory, rolling hills, river valleys, lakes, and eventually, as the climate warmed slightly, forests and wetlands rich with wildlife. People lived there, hunted there, buried their dead there. For thousands of years, Doggerland was simply part of the European mainland, with no hint that would one day exist only as a name on a map of the seafloor. On the opposite side of the world, a similar exposure of continental shelf created Beringia, the land bridge connecting northeastern Siberia to Alaska across what is now the Bering Strait. Beringia was not a thin, precarious strip of land, as the term bridge might suggest. It was an expansive region, in places more than 1,000 kilometers wide, covered in steppe tundra vegetation capable of supporting large herds of grazing animals. Mammoths crossed it. Horses crossed it. Eventually, generation after generation of human populations crossed it as well, in the slow migratory movements that would eventually populate the entire Western Hemisphere. Further south and east, the exposed continental shelves of Southeast Asia joined the islands of Sumatra, Java, Borneo, and the Malay Peninsula into a single continuous landmass that researchers call Sundaland, an area roughly the size of India, now mostly submerged beneath the shallow waters of the South China Sea and the Java Sea. The climate across this transformed world was, in most regions, dramatically different from anything we experience today. Vast areas that are now temperate forests or grassland were instead covered in a unique ecosystem called steppe tundra, cold, dry, and largely treeless, but surprisingly productive, supporting enormous herds of grazing megafauna. This was a world of woolly mammoths and woolly rhinoceroses, of giant deer with antlers spanning nearly 4 meters, of cave lions and saber-toothed cats hunting across open plains that stretched, in places, from what is now France to what is now Korea. Human populations during this period were small, highly mobile, and intensely adapted to this cold, resource-patchy environment. Groups followed the seasonal movements of migratory herds, structuring entire ways of life around the availability of large game. Shelter, when not provided by caves, was often built from the materials available in a landscape with very few trees. Bones and tusks of mammoths arranged into frameworks, covered with hides for insulation against temperatures that could plunge dramatically below freezing for much of the year. Clothing technology had to be sophisticated enough to survive in conditions where exposed skin could mean death within hours, and the archaeological record shows evidence of eyed needles, suggesting tailored, fitted clothing rather than simple draped hides. This was not a world of constant suffering. Despite its harshness, human populations at the last glacial maximum were skilled, resourceful, and successful within the environment they inhabited. They had spent tens of thousands of years adapting to exactly these conditions: cold, dry, open landscapes filled with large, huntable animals, connected by land bridges that allowed movement across distances that would later become impossible once the seas rose. This was the world humans knew. A world of ice sheets and exposed seafloors, of mammoth herds on dry land where oceans now stretched to the horizon, of coastlines hundreds of kilometers further out than the coastlines we know today. And without any warning that history could record, it was about to disappear. The world humans knew had endured for thousands of years. Generation after generation had been born into the same frozen landscape. Vast white horizons stretched across the north. Mammoths wanted the open plains, and enormous walls of ice stood so permanent that no one could have imagined they would ever disappear. To the people living beneath their shadow, the glaciers were as eternal as the stars. Yet, far beyond anything a human eye could observe, the forces that governed this frozen world had already begun to change. The remarkable thing about the end of the last ice age is that it did not begin with an explosion, an earthquake, or some sudden catastrophe. There was no single day when the ice started melting. No ancient observer could have pointed toward the horizon and declared that the Great Thaw had arrived. Instead, the story began with something almost unimaginably slow. It began in space. Our planet does not travel around the sun in a perfectly steady, unchanging way. Earth is constantly moving through subtle celestial rhythms that unfold over tens of thousands of years. These slow changes are so gradual that no human civilization has ever witnessed a complete cycle, yet they have repeatedly transformed the climate of the entire planet. Today, scientists call these patterns the Milankovitch cycles, named after the Serbian mathematician Milutin Milankovic, who spent years calculating how Earth's orbit influences climate. Fortunately, the basic idea is far simpler than the mathematics behind it. Imagine Earth as a spinning top circling a campfire. Sometimes its path around the fire becomes slightly more circular. At other times it stretches into a slightly more elongated oval. The angle at which the top leans also changes, becoming a little steeper before gradually becoming more upright again. Even the direction that the tilted top point slowly wobbles, much like a spinning toy that changes direction before finally coming to rest. None of these movements happen quickly. Each requires thousands, sometimes tens of thousands, of years to complete. Individually, they seem insignificant. Together, they determine how much sunlight reaches different parts of Earth during different seasons. And that changes everything. Around 20,000 years ago, these astronomical cycles aligned in a way that gradually increased the amount of summer sunlight reaching the northern hemisphere. The difference was surprisingly small. It was not enough to make summers suddenly hot. It was not enough to transform frozen landscapes overnight. But year after year, century after century, each northern summer became just slightly more capable of melting winter snow. Normally, snow that survives the summer becomes part of a glacier, Layer upon layer accumulates until enormous ice sheets slowly grow thicker. Now the balance had shifted. For the first time in thousands of years, slightly more ice melted during summer than winter could replace. At first, almost nothing appeared to change. The edges of glaciers retreated only a few meters. Tiny streams of meltwater trickled across the frozen ground. Lakes formed where there had once been only solid ice. To the people living nearby, these would have seemed like ordinary variations in the landscape. No one could have realized they were witnessing the opening chapter of one of the greatest transformations in Earth's history. But nature has a habit of amplifying even the smallest changes. Fresh snow reflects most sunlight back into space. It is one of the brightest natural surfaces on our planet. Dark soil, forests, and open water behave very differently. Instead of reflecting sunlight, they absorb it. As glaciers slowly retreated, they exposed patches of darker land beneath them. These darker surfaces absorb more solar energy, warming the surrounding environment even further. That additional warmth melted more ice, which exposed even more dark ground, which absorbed even more heat. Scientists call this the ice albedo feedback. It is one of nature's most powerful feedback loops, a process in which one small change creates another, larger change, which then strengthens the original one. The thaw was beginning to feed itself. Each summer became slightly warmer than the one before. Each winter rebuilt a little less of what had been lost. The frozen giants that had dominated the landscape for tens of thousands of years were slowly beginning to surrender. Yet sunlight alone was not working in isolation. The oceans, too, were changing. Cold seawater can hold enormous amounts of dissolved carbon dioxide. Much like a chilled bottle of sparkling water holds more gas than a warm one. As the climate slowly warmed, parts of the world's oceans began releasing some of that stored carbon dioxide back into the atmosphere. This was not the original cause of the warming. Rather, it acted like another hand gently turning up the thermostat. Carbon dioxide is a greenhouse gas. It allows sunlight to enter Earth's atmosphere while slowing the escape of heat back into space. As atmospheric carbon dioxide gradually increased, more warmth remained trapped around the planet. The result was subtle at first. Temperatures rose by fractions of a degree over many generations. No single lifetime experienced a dramatic transformation. A child born during the earliest stages of the warming likely died in a world that looked remarkably similar to one into which they had been born. But across centuries, across dozens of generations, those tiny differences accumulated. The glaciers became thinner. The rivers carried more meltwater every spring. Valleys that had remained frozen for countless millennia slowly awakened beneath the sunlight. Plants expanded northward. Animals followed fresh grasslands. Human communities adjusted their seasonal migrations without realizing they were responding to the beginning of a planetary revolution. For thousands of years, the warming remained surprisingly gentle. Earth seemed to be changing with patience. There was no reason to believe the transformation would become violent. No reason to suspect that coastlines would eventually retreat by hundreds of kilometers. No reason to imagine that entire countries would disappear beneath rising seas. The planet appeared to be healing itself gradually, almost peacefully. But beneath the vast ice sheets of North America and Northern Europe, immense pressures were quietly building. Millions of cubic kilometers of ancient ice were weakening from below. Hidden lakes formed beneath glaciers. Gigantic rivers of meltwater searched for pathways through the ice. The frozen world was becoming unstable. It simply had not revealed it yet. The first signs of the Great Thaw were almost invisible, so slow that no human could have recognized them. Yet those gentle beginnings would eventually unleash floods unlike anything our species had ever witnessed. The thaw had begun quietly, but it would not stay quiet for long. The first signs of the Great Thaw had been almost impossible to notice. For thousands of years, the glaciers had surrendered only a little more ground with each passing summer. Tiny streams had formed where none had existed before. Small lakes appeared along the edges of the ice. To anyone living through those generations, the world still felt familiar. The frozen giants remained, towering over the landscape much as they always had. But deep within the heart of the great ice sheets, something extraordinary was beginning to happen. The slow warming that had quietly reshaped the planet for centuries was approaching a tipping point. Around 14,600 years ago, Earth's climate entered one of the most dramatic warming episodes ever recorded in the geological record. Scientists call this period the boiling warming event. Unlike the gradual changes that came before it, this shift happened with astonishing speed. Temperatures across much of the northern hemisphere climbed rapidly. Landscapes that had remained frozen for thousands of years suddenly experienced summers unlike anything they had known since before the Ice Age reached its peak. The ice could no longer keep up. Every warm season now removed more of the great glaciers than winter could rebuild. The balance had finally broken. Imagine standing beside an enormous block of ice beneath the spring sun. At first, almost nothing seems to happen. A few drops appear. Then tiny streams begin to run. But eventually the entire structure weakens until enormous sections suddenly collapse under their own weight. That simple image captures what was happening on a planetary scale. The Laurentide ice sheet covering North America and the Scandinavian ice sheet across northern Europe had grown over tens of thousands of years. Now they were beginning to fail. Their surfaces became riddled with meltwater streams. Brilliant blue lakes formed across the tops of glaciers, reflecting the sky like mirrors scattered across endless fields of ice. Each summer these lakes grew larger. The water searched relentlessly for cracks. When it found them, it plunged downward through vertical shafts called moulins, carrying tremendous amounts of heat deep into the heart of the glacier. Instead of melting only from above, the ice now began weakening from within. Hidden rivers carved tunnels beneath the glaciers, gigantic cavities filled with water. The enormous weight of the ice slowly became unstable. Then came one of the fastest episodes of sea level rise our planet has experienced since the end of the last ice age. Scientists call it Meltwater Pulse 1A. In geological terms, it happened almost instantly, over only a few centuries, perhaps even less in some regions. Global sea levels rose by as much as 16 meters. 16 meters. That is roughly the height of a 5-story building. To modern eyes, a few centuries may sound like a long time, but for Earth, it is barely a heartbeat. Generations of people watched the coastline creep steadily inland. Children grew into adults while beaches disappeared. Forests that had stood safely above the waves slowly became marshes before finally vanishing beneath the sea. Entire valleys transformed into estuaries. The shoreline that grandparents had known no longer existed for their grandchildren. No single wave caused this transformation. The ocean simply refused to stop advancing. The reason lay inside the collapsing ice sheets themselves. Many glaciers acted like gigantic natural dams, trapping vast lakes of meltwater behind walls of ancient ice. Those icy barriers had held for centuries, but as temperatures continued rising, they weakened. Eventually the pressure became too great. Without warning, entire sections of glacial ice fractured apart. Millions of tons of water burst free. Enormous torrents thundered across the landscape, carrying boulders the size of houses, uprooting forests, carving deep valleys into solid rock, and rushing toward the oceans with unimaginable force. Some floods released more fresh water in a matter of days than many of today's largest rivers discharge in centuries. These were not ordinary floods. They were among the greatest floods the earth has known. Far downstream, rivers that quietly flowed through frozen valleys suddenly became raging torrents. Channels widened, riverbanks collapsed. New lakes appeared almost overnight. Wetlands spread across low-lying plains. The geography of entire regions changed within a single human lifetime. Along the world's coastlines, another transformation unfolded. The rising ocean advanced a little farther inland each generation. Salt water crept into freshwater marshes. River mouths widened. Small islands disappeared beneath the waves. Coastal forests slowly drowned as seawater poisoned their roots. Ancient hunting camps established beside rivers found themselves standing closer and closer to the water each passing decade. Families returned to familiar seasonal camps only to discover that the shoreline had moved. Some settlements were abandoned, others relocated to higher ground. Still others disappeared entirely beneath the expanding sea, leaving behind only stone tools and scattered bones that will remain hidden underwater for thousands of years. The changing coastline altered far more than where people lived. It transformed how they survived. The broad coastal plains that had once supported grazing animals steadily vanished. Migration routes followed by mammoths, bison, horses, and reindeer became narrower every generation. River crossings disappeared beneath deep water. Land bridges that had connected distant regions slowly began breaking apart. Hunters found themselves forced to travel farther in search of familiar herds. The landscape that had guided countless generations was becoming unfamiliar. Perhaps the strangest part of all was that nobody living through it could have understood the full scale of what was happening. A family might notice their favorite fishing place had disappeared. Another might remember a forest that no longer existed. An elder could tell stories of valleys that younger people had never seen. Each observation seemed local. Each seemed isolated. No one could climb high enough to watch the coastlines of entire continents retreat. No one could see that glaciers thousands of kilometers away were collapsing into rivers of meltwater. Only from our modern perspective can we recognize that all these separate experiences belong to the same extraordinary event. The Great Thaw had entered a new phase. The frozen world was no longer changing slowly. It was beginning to unravel. And once the oceans began rising, there was no force on Earth capable of asking them to stop. The water did not ask permission. It simply rose. For thousands of years, it had seemed that the ice age was finally coming to an end. The glaciers were retreating. The rivers flowed stronger with every passing century. Grassland spread across lands that had once been locked beneath ice, and both animals and humans gradually expanded into these newly open landscapes. The Earth appeared to be following a single direction, warmer, greener, more familiar. If you had been alive then, you might have believed the worst was over. But nature had one final surprise waiting. Around 12,900 years ago, something extraordinary happened. The warming stopped. Almost as subtly as it had begun, temperatures across much of the northern hemisphere plunged once again. Within only a few decades, perhaps even within a single human lifetime in some regions, the climate shifted dramatically. The forests that had begun reclaiming the land struggled to survive. Snow returned earlier each autumn. Winters became longer and harsher. Glaciers that spent centuries retreating began advancing once more. It was as though the Ice Age had changed its mind. Scientists call this mysterious period the Younger Dryas, named after the tiny Arctic flower Dryas octopetala, whose pollen suddenly became abundant across Europe. It marks one of the most puzzling climate reversals ever discovered. For roughly 1,200 years, Earth slipped back toward glacial conditions. The Great Thaw had paused. Why it happened remains one of paleoclimatology's greatest mysteries. The leading explanation begins not in the sky, but in the ocean. Today, enormous currents constantly move warm and cold water around the globe. One of the most important is the Atlantic meridional overturning circulation, often described as a giant planetary conveyor belt. Warm tropical water travels northward across the Atlantic Ocean. As it reaches colder northern seas, it cools, becomes denser, and sinks deep beneath the surface before eventually flowing back south. This continuous circulation redistributes heat around the planet, helping keep northern Europe far warmer than it otherwise would be. But this vast engine depends on one crucial ingredient: salt. Cold salt water is heavier than fresh water. If too much fresh water suddenly enters the North Atlantic, the surface water becomes lighter and struggles to sink. The entire circulation can weaken dramatically. During the end of the Ice Age, enormous glacial lakes had formed along the edges of the retreating Laurentide ice sheet. Some scientists believe one or more of these lakes catastrophically drained into the North Atlantic. Millions of cubic kilometers of fresh water may have poured into the ocean over a relatively short period. The ocean's balance changed. The great conveyor slowed, perhaps even stopped for a time. Without warm water continually flowing northward, temperatures across much of the northern hemisphere dropped rapidly. It was a chain reaction beginning with melting glaciers that unexpectedly produced renewed cold. Yet science rarely settles for only one explanation. Another hypothesis has captured the imagination of both researchers and the public alike. According to the younger Dryas impact hypothesis, fragments of a comet, or perhaps an asteroid, may have exploded above or struck parts of North America around the beginning of the younger Dryas. Supporters point to microscopic diamonds, unusual layers of soot, and other geological clues that they argue indicate an extraterrestrial impact. Such an event, they suggest, could have ignited massive wildfires, filled the atmosphere with dust, disrupted climate systems, and accelerated ecological collapse. It is a dramatic idea, but it remains highly controversial. Many scientists argue that the available evidence is incomplete or could be explained by other natural processes. After years of debate, no scientific consensus has emerged. For now, the comet remains a fascinating possibility rather than an accepted explanation. Whatever the cause, the consequences were unmistakable. The climate turned cold again across Europe and North America. Expanding forests slowed or retreated. Tundra returned to places where shrubs and young trees had only recently begun to grow. Animals adjusted their migration routes once again, following shifting vegetation across an increasingly unpredictable landscape. For human communities, the younger Dryas was more than a change in temperature. It interrupted a future that had only just begun. In the land stretching from the eastern Mediterranean through modern-day Israel, Palestine, Jordan, Syria, and surrounding regions, groups known today as the Natufians had already begun experimenting with a different way of life. Instead of constantly moving after game, some communities stayed longer in one place. They harvested wild cereals, built more permanent homes, stored food. The earliest seeds of agriculture were quietly taking root. Then the climate changed. Cooler, drier conditions reduced the availability of many wild plants these communities depended upon. Harvest became less reliable. Some settlements were abandoned. Others adapted by returning to greater mobility or expanding the variety of foods they collected. Ironically, many archaeologists believe these hardships may have encouraged the eventual development of true farming after the younger Dryas ended. Necessity became innovation. Once again, climate reshaped the course of human history. For 12 centuries, the world remained caught between two ages, not fully glacial, not fully warm, a strange pause between one Earth and another. Then, almost as abruptly as it had begun, the younger Dryas ended. Temperatures rose rapidly. The Great Thaw resumed. The glaciers once again retreated. The Holocene, the stable, warm age in which human civilization would flourish, was finally about to begin. Yet one question still echoes through every ice core, every layer of ancient sediment, and every scientific conference devoted to Earth's past. Why did it happen? Even today, despite satellites, supercomputers, and decades of research, no one can answer with complete certainty. Just when the world seemed to be healing, it turned cold again, and no one fully knows why. For more than 1,000 years, the Earth had endured an unexpected return to cold. The glaciers had advanced once more. The forests had retreated. Human communities had adapted as best they could, wading through generations of uncertainty beneath an unpredictable sky. Then, almost as suddenly as it had begun, the cold released its grip. Around 11,700 years ago, the younger Dryas came to an end. Temperatures rose with remarkable speed. The Great Thaw resumed. This time, however, there would be no second return to ice. The planet was entering a new age. The Holocene had begun. The surviving glaciers, weakened by thousands of years of warming, once again surrendered to the sun. Their edges retreated farther north every generation. Rivers swelled with meltwater. Great lakes expanded, and the oceans, fed by countless rivers flowing from every continent, continued their slow but relentless rise. To us today, sea level is simply a number measured by satellites. to the people living at the end of the Ice Age, it was something far more personal. It was a shoreline moving closer every year, a familiar beach disappearing beneath the waves, a favorite hunting ground becoming a marsh, a river valley slowly transforming into an inlet of the sea. The water never rushed all at once. Most of the time, it simply kept coming, patient, relentless, impossible to stop. One of the greatest victims of this rising ocean was a vast land that no longer appears on any modern map. Today, we know it as Doggerland. Thousands of years ago, Doggerland connected Britain to mainland Europe. It was not merely a narrow bridge of land. It was an enormous landscape of forests, rivers, freshwater lakes, rolling hills, and fertile plains rich with wildlife. Red deer grazed beneath broad forests. Wild horses crossed open grasslands. Early hunter-gatherers built camps beside winding rivers and followed seasonal migrations across a landscape that stretched as far as the eye could see. Generation after generation called a home. Then the sea began to claim it. At first, only the lowest valleys flooded. Wetlands expanded. Small lakes merged with the ocean. Communities gradually moved toward higher ground. But the land grew smaller with every passing century. The coastline retreated farther inland. Eventually, only scattered islands remained. Then, around 8,200 years ago, nature delivered one final blow. Off the coast of modern Norway, an enormous underwater landslide known today as the Storegga Slide triggered one of the largest tsunamis ever to strike northern Europe. Towering walls of water swept across what remained of Doggerland. The final fragments of this lost world disappeared beneath the sea. Today, fishing boats occasionally recover ancient tools, animal bones, and pieces of worked wood from the floor of the North Sea. Silent reminders that beneath the waves lies an entire forgotten landscape. Far to the southeast, another enormous transformation was unfolding. During the Ice Age, much of Southeast Asia had formed a single continuous continent known as Sundaland. Modern Indonesia did not exist. Instead, Sumatra, Java, Borneo, and the Malay Peninsula were connected by vast lowland forests, broad river systems, and fertile plains stretching for thousands of kilometers. As sea levels continued rising, these lowlands slowly disappeared. River valleys filled with seawater. The sea carved new coastlines. One enormous continent gradually fragmented into hundreds of islands. The geography of Southeast Asia was rewritten forever. Entire ecosystems became isolated from one another. Animal populations that had once shared the same forests evolved separately. Human communities found themselves living on islands that had once been connected by dry land. On the opposite side of the world, another land bridge quietly vanished. Beringia had once linked Siberia and Alaska across a broad expanse of steppe tundra. For thousands of years, animals and humans had crossed freely between Asia and North America. It was one of the most important migration corridors in human history. Now, rising seas flooded the lowlands. The Bering Strait slowly formed. The route closed forever. The two continents, once connected by land, became separated by ocean. No one standing on its shores could have known. They were witnessing the end of a pathway that had shaped the settlement of an entire hemisphere. Elsewhere, another great flood may have entered human memory. Some researchers have suggested that rising Mediterranean waters eventually spilled through Bosporus into the lower-lying Black Sea basin, rapidly expanding its shoreline. Whether this flooding occurred suddenly or gradually remains the subject of scientific debate. But the possibility has fascinated historians for decades. Could such an event have inspired some of humanity's oldest flood legends? No one knows for certain. Yet remarkably similar stories appear across civilizations separated by thousands of kilometers. In Mesopotamia, ancient texts describe a catastrophic flood sent to destroy the world. The Hebrew Bible tells of Noah's Ark. Greek mythology speaks of Deucalion surviving a great deluge. Ancient Indian traditions tell of Manu preserving life upon a great boat. Even indigenous cultures across the Americas, Australia, and the Pacific preserve stories of rising waters that transformed the world. These stories emerge independently, separated by oceans and centuries. Perhaps they are coincidence. Perhaps they preserve distant cultural memories passed from generation to generation. Or perhaps they simply reflect a universal human experience. For countless communities living at the end of the Ice Age, the sea truly did rise. Entire villages disappeared. Families abandoned ancestral homes. Sacred places vanished beneath the waves. As coastlines retreated inland, people were forced to move again and again. Each generation walked farther from the places where their grandparents had once hunted, fished, and buried their dead. The maps in their minds slowly became useless. The world they thought they understood no longer existed. Yet humanity survived. People adapted. They carried their traditions inland. They built new settlements beside new rivers. They learned new landscapes. And somewhere within their stories, perhaps only as fading echoes whispered around campfires, memories of the drowned world remained alive. Today, satellites can map those lost coastlines hidden beneath the oceans. Marine archaeologists can recover tools from lands that no longer exist. Scientists can reconstruct the changing shape of continents with astonishing precision. But no technology can fully recover what was lost. Entire worlds disappeared beneath the waves, and only fragments of memory remained. The rising seas did not transform the world alone. While coastlines disappeared beneath the waves and glaciers retreated toward the poles, another tragedy was unfolding across the continents. It happened quietly, not in a single catastrophic day, not through one great disaster, but generation after generation, the largest animals on Earth began to disappear. For millions of years, giants had ruled the Ice Age. Across the frozen plains of North America wandered enormous Columbian mammoths, woolly mammoths, mastodons, giant bison, and camels unlike any alive today. In Europe and Asia, woolly rhinoceroses grazed beside towering mammoths, while cave lions stalked the open tundra. South America belonged to giant ground sloths the size of elephants, and armored glyptodons that resembled living tanks. Australia had its own extraordinary giants, including massive kangaroos and reptiles that dwarfed anything living there now. To the humans who shared their world, these creatures were simply nature. They had always been there. Yet, within only a few thousand years, many of them were gone. Scientists call this event the late Quaternary megafaunal extinction. It was one of the greatest losses of large animals since the extinction of the dinosaurs. The obvious question is also the most difficult. Why did they disappear? For decades, researchers have debated two competing explanations. The first blames the changing climate. As the Ice Age ended, the world transformed with astonishing speed. The endless steppe tundra that had stretched across much of the northern hemisphere gradually vanished. Forests spread into areas that had once been open grasslands. Wetlands expanded. Temperatures rose. Rainfall patterns shifted. The familiar habitats that had supported mammoths, woolly rhinoceroses, giant deer, and countless other species slowly disappeared. Animals that had evolved for cold, dry landscapes suddenly found themselves living in warmer, wetter worlds. Some adapted, many could not. But climate alone does not answer every question. The second explanation places humans at the center of the story. It is known as the overkill hypothesis. By the end of the Ice Age, modern humans had spread across nearly every continent except Antarctica. They carried increasingly sophisticated hunting technology. Stone spear points became sharper. Cooperation within hunting groups improved. Knowledge passed from one generation to the next. Unlike wolves or cave lions, humans could plan. They could trap. They could coordinate attacks over great distances. Even slow reproduction made many giant animals especially vulnerable. A mammoth did not produce large numbers of offspring each year. Losing only a few adults annually could gradually push an entire population toward collapse. This idea gained particular attention in North America. The fossil record suggests that many large mammals disappeared not long after humans became widespread across the continent. Within a relatively short period, mammoths, mastodons, giant ground sloths, American lions, short-faced bears, camels, horses, and dozens of other large species vanished forever. Some researchers see this timing as powerful evidence that expanding human populations accelerated their extinction. Yet the picture becomes more complicated elsewhere. In Eurasia, humans and mammoths had lived together for tens of thousands of years before mammoth populations finally declined. If hunting alone caused extinction, why had they survived together for so long? That question points toward a more likely answer. Perhaps neither theory is completely correct. Instead, the giants faced two enemies at once. As warming climates reduced their habitats, food became scarcer. Populations became smaller and more isolated. Then human hunters entered landscapes where the surviving herds were already under pressure. What climate weakened, human hunting may have finished. Together, the two forces became far more destructive than either one alone. Perhaps nowhere is this story more poignant than the final days of the mammoths themselves. Most disappeared from the mainland around 10,000 years ago, but not all. A few isolated populations survived on remote islands after rising seas cut them off from the outside world. One of these refuges was Wrangel Island, far north of Siberia. There, a small population of woolly mammoths continued wandering the Arctic tundra for nearly 6,000 more years. When the pyramids of ancient Egypt were already rising beside the Nile, mammoths were still alive. Only after centuries of isolation, shrinking genetic diversity, and changing environmental conditions did the final survivors disappear. The last chapter of the mammoths was written not during the Ice Age, but during human civilization. The disappearance of these giants changed far more than the list of animals living on Earth. Entire ecosystems had evolved around them. Mammoths knocked down young trees while searching for food, helping maintain vast open grasslands. Giant herbivores spread seeds across enormous distances. Their footprints collected rainwater, creating tiny wetlands where insects and plants thrived. Predators depended upon them. Scavengers fed upon their carcasses. Even the soil itself changed through their constant movement. When the giants vanished, the landscape began changing with them. Forests spread into former grazing grounds. Grasslands shrank. Entire food webs reorganized. Species that had depended upon these enormous animals either adapted or disappeared alongside them. The world became quieter, not all at once, but century after century, one familiar sound after another faded into silence. The thunder of mammoth herds, the deep calls of mastodons, the heavy footsteps of giant ground sloths, the roar of saber-toothed cats echoing across the plains. One by one, they became memories. For early humans, the change must have been almost impossible to understand. Children grew up hearing stories about creatures their grandparents had hunted, but they themselves had never seen. The giants slowly passed from living reality into legend. Today, we uncover their bones buried beneath frozen ground, preserved in caves, or resting beneath ancient lake beds. Each fossil reminds us that our world was once home to creatures that seem almost mythical today. Yet they were real. They walked the same earth we walk now. They breathed the same air. And for thousands of years, humans shared the planet with them. Then, almost without anyone realizing it, the giants vanished, and the world they shaped vanished with them. When the last great glaciers finally loosened their grip upon the earth, the world did not simply become warmer. It became unfamiliar. The coastlines people had known were gone. Ancient migration routes had disappeared beneath rising seas. The great herds of mammoths, mastodons, and giant bison that had sustained countless generations were growing smaller with every passing century. The Ice Age was over, and humanity was entering a world no one had ever experienced before. For our ancestors, survival had always depended on understanding the landscape, knowing where the rivers flowed, where the herds migrated, where edible plants appeared each season. But now, those answers were changing. The map, carried in every hunter's memory, was slowly becoming obsolete. Some valleys no longer existed. New lakes had formed where forests once stood. The shoreline continued creeping inland. Entire regions that previous generations had called home were now hidden beneath the sea. Humanity faced a challenge unlike any before, not because people had become weaker, but because the world itself had changed. The disappearance of the Great Ice Age animals forced one of the most important adaptations in human history. For thousands of years, many communities have relied heavily on hunting enormous herbivores. A single mammoth could provide meat for weeks, hides for shelter, bones for tools, and tusks for construction. Now those giants were becoming increasingly rare. Hunters could no longer depend upon them. Instead, people broadened their diets. They hunted deer, gazelle, wild sheep, rabbits, and birds. They became skilled fishermen, casting nets into rivers that had grown larger after glaciers melted. Coastal communities harvested shellfish, crabs, and countless other marine resources from shorelines that had only recently emerged, or were slowly disappearing again. Wild fruits, berries, nuts, roots, and edible plants became increasingly important. Instead of depending upon one enormous source of food, humans learned to gather nourishment from many different places. Archaeologists call this a broad-spectrum economy. It was one of humanity's greatest strengths, flexibility. Rather than waiting for the world to return to what it had been, people changed with it. As the climate gradually stabilized, another remarkable transformation quietly began. In a region stretching across parts of today's Iraq, Syria, Turkey, Israel, Palestine, Jordan, and neighboring lands, a place we now call the Fertile Crescent, some communities noticed something extraordinary. Certain grasses returned every year. Wild wheat and barley flourished in predictable locations. Seeds scattered near camps often sprouted again the following season. For countless generations, people had gathered these grains exactly as nature provided them. Now, perhaps without fully realizing its significance, some began helping nature along. They cleared small patches of land, protected useful plants, collected seeds from the strongest harvests, returned to the same places year after year. These were not yet true farms. No one suddenly invented agriculture overnight. Instead, farming emerged through hundreds of tiny experiments carried out across many generations. Each season taught a new lesson. Each harvest revealed another possibility. Ironically, it may have been the hardships of the younger Dryas that encouraged these experiments. When wild food became less reliable, people searched for ways to make nature more predictable. By learning to influence the growth of plants, humanity took its first uncertain steps toward changing the landscape itself. At the same time, people continued moving into lands that had remained buried beneath ice for tens of thousands of years. As glaciers retreated northward, entirely new territories opened before them. Families followed rivers into valleys no human had ever explored. Forests spread across northern Europe. Grasslands expanded into Canada. Mountain passes that had long been blocked by ice finally became accessible. With every generation, humanity occupied more of the newly revealed earth. Migration was no longer driven only by wandering herds. Now it followed opportunity. Fresh water, fertile soil, abundant forests, rich fishing grounds. The warming world was creating entirely new homes. These changing landscapes inspired new technologies as well. Stone tools became increasingly specialized. Fine blades replaced heavier hunting implements in many regions. Fishing hooks carved from bone appeared beside woven nets and wooden traps. Grinding stones became common as people processed increasing amounts of grain and wild seeds. Pottery slowly emerged, allowing food and water to be stored more efficiently. Homes changed too. Instead of temporary camps that move with the seasons, some communities built more permanent villages. Stone foundations replaced simple shelters. Storage pits preserved food through difficult winters. For the first time in human history, some people began imagining that they might remain in one place for years rather than months. Yet perhaps the greatest adaptation was one that left almost no trace for archaeologists to uncover. It happened inside the human mind. Imagine a child sitting beside a fire, listening to an elder describe a world that no longer existed. A world where mammoths crossed endless plains, where Britain was joined to Europe, where hunters walked across lands now hidden beneath the sea, where rivers flowed through valleys swallowed by the ocean. To the child, these stories might have sounded impossible, almost mythical, but to the elder, they were memories passed down from grandparents who had witnessed those changes with their own eyes. Across thousands of years, such memories may have become legends, stories of great floods, of lands lost beneath the waves, of winters that refused to end. Nearly every civilization on Earth preserves ancient traditions describing catastrophic floods or dramatic changes in the natural world. Not every myth records real history. Yet myths often preserve emotional truths long after specific details have faded, long before writing existed. Stories became humanity's memory. Around campfires, across countless generations, people carried fragments of a changing world into the future. By the time the Ice Age finally faded into history, humanity was no longer the same species that had entered it. People hunted differently, lived differently, built differently, thought differently. The changing climate had not simply reshaped rivers, forests, coastlines, and glaciers. It had reshaped us. Humans did not just survive this transformation, they were remade by it. For nearly 15,000 years, the Earth had been changing almost without pause. Ice sheets had risen and fallen. Sea levels had swallowed entire continents. The giants of the Ice Age had disappeared. Human communities had crossed vanished land bridges, abandoned flooded coastlines, and learned to survive in landscapes their ancestors would scarcely have recognized. Then, the planet finally grew quiet. Around 11,700 years ago, the last chapter of the Ice Age came to an end. The younger Dryas ended almost as suddenly as it had begun. Temperatures rose rapidly. The great glaciers resumed their retreat. And this time, the cold never returned. Earth had entered a new geological epoch. Scientists call it the Holocene, compared with the violent climate swings of the Pleistocene that came before it. The Holocene was remarkably stable. The seasons became more predictable. Rainfall patterns settled into long-term rhythms. Temperatures fluctuated far less dramatically than they had for hundreds of thousands of years. For the first time in an incredibly long time, people could begin planning not only for the next season, but for the next generation. That stability changed everything. Imagine trying to grow crops in a world where temperatures could suddenly collapse for centuries, where rivers constantly change course, where glaciers advance without warning, where coastlines moved every lifetime. Agriculture would have been nearly impossible. Permanent villages would have struggled to survive. Civilization itself would have faced enormous obstacles. But now, the climate offered something it rarely had before: consistency. The same rivers flooded each year. The same grasslands returned each spring. The same growing seasons repeated again and again. Nature became predictable enough for humans to invest in the future. Across the Fertile Crescent, small farming experiments gradually became permanent agriculture. Wild wheat and barley slowly transformed into domesticated crops. Goats, sheep, cattle, and pigs were brought under human care. Families who had once followed migrating animals now remained beside their fields throughout the year. Villages became towns. Towns became cities. Trade routes connected distant peoples. Writing emerged. Kingdoms rose. Empires followed. None of these developments happened overnight. Each built upon the foundation laid by a remarkably stable climate. Historians call this transformation the Neolithic Revolution. It was not simply a revolution in farming. It was a revolution in how humans lived. For hundreds of thousands of years, our ancestors had adapted to nature. Now, increasingly, they began reshaping nature itself. Forests were cleared, fields were planted, rivers were redirected, animals were domesticated. Human civilization was no longer merely surviving within the environment. It was beginning to transform it. The coastlines we know today also took their familiar shape during this period. Britain became an island. Indonesia became an archipelago. The Bering Strait permanently separated Asia from North America. The North Sea covered the lost world of Doggerland. Modern beaches, bays, estuaries, and river mouths slowly settled into forms that remain recognizable today. When we look at a world map, we often assume it has always looked this way. It has not. The continents remain the same. But the coastlines, the places where land meets sea, were rewritten by the end of the Ice Age. Even the ecosystems surrounding us were shaped during this transition. Forests spread across Europe. Grasslands stabilized across many regions. Modern rivers carved their present channels. The distribution of countless plants and animals reflects the warming that followed the last ice age. In many ways, the natural world we experience today is still living in the aftermath of the Great Thaw. Yet Earth's story never truly ends. Some scientists have suggested that human activity has now become so influential that we may be entering another geological chapter, one often referred to as the Anthropocene. Unlike the natural climate shifts that ended the Ice Age, this proposed epoch is defined by humanity's growing influence on the planet through agriculture, cities, industry, and global environmental change. Whether the Anthropocene will one day become an officially recognized geological epoch remains a subject of ongoing scientific discussion. But one thing is beyond debate. Humans have become a force capable of reshaping the Earth itself, a remarkable reversal. For most of our history, the planet changed us. Now, increasingly, we are changing the planet. The story of the Great Thaw is not merely the story of melting ice. It is the story of how the modern world came into existence. Every city, every farm, every road, every nation, every language, every civilization exists because the climate eventually became stable enough for them to grow. Had the glaciers never melted, had the seas never risen, had the Holocene never arrived, human history would have unfolded along an entirely different path. When we stand beside an ocean, walk through a forest, or look across a fertile valley, we are looking at landscapes shaped by one of the greatest transformations our planet has ever experienced. The Ice Age did not simply end. It created the world we inherited. Everything we call civilization was built on the calm that followed the storm. For thousands of years, the end of the last ice age has often been imagined as a peaceful transition, a slow warming, a gentle retreat of glaciers, the quiet arrival of the modern world. But the evidence tells a very different story. The Great Thaw was one of the most dramatic transformations our planet has ever experienced. Entire ice sheets kilometers thick collapsed. Sea levels rose by more than 120 meters. Great floods reshaped continents. Ancient coastlines disappeared beneath the waves. Land bridges that had connected entire continents vanished forever. The giants of the Ice Age, mammoths, mastodons, saber-toothed cats, giant ground sloths, and countless others, slowly disappeared from the earth. Even as the planet warmed, the younger Dryas reminded humanity that nature could reverse course without warning, plunging much of the northern hemisphere back into centuries of bitter cold. It was not one disaster. It was thousands of years of constant change. Yet, perhaps the most remarkable part of this story is not what was lost. It is what survived. Again and again, human communities adapted. When the mammoths disappeared, they found new sources of food. When the coastlines retreated, they built new homes farther inland. When familiar landscapes vanished, they learned entirely new ways of living. And when the climate finally stabilized, they did something no species had ever done before. They began planting fields, building villages, creating cities, writing history. Everything we recognize as civilization was built upon the foundation left behind by the Great Thaw. In a strange way, the destruction of the old world made the modern one possible. The streets beneath our feet were once frozen tundra. The fertile valleys that feed billions today were carved by rivers flowing from melting glaciers. The coastlines that define our maps were drawn by rising seas within the memory of our distant ancestors. The world we call normal is one of the newest versions of Earth that has ever existed. And perhaps that is the greatest lesson hidden within the end of the Ice Age. Nothing about our planet is permanent. Mountains rise, glaciers grow, Oceans advance, forests spread, species appear, species disappear. The Earth is always changing. Humanity has never existed outside that story. We have always adapted alongside it. The Great Thaw reminds us that resilience is one of our oldest inheritances. Our ancestors crossed flooded landscapes, survived collapsing ecosystems, endured sudden cold, and built entirely new ways of life from the ruins of the old. Because they adapted, we are here. So the next time you stand beside the ocean, walk through a forest, or watch a river winding toward the sea, remember that you are looking at a world shaped by one of the greatest transformations in Earth's history. A world born from melting ice, a world inherited from survivors, and a world that, like every world before it, will continue to change. Thank you for joining me on this journey through the end of the last ice age. If you enjoyed this documentary and want to explore more of Earth's incredible history, don't forget to like the video, subscribe to the channel, and share it with someone who loves discovering the stories hidden beneath our planet's past. Until next time, sleep well, and let the echoes of the Great Thaw carry you into peaceful dreams.